Changing capacitance 2. What we're going to do this time is we're going to charge the capacitor with nothing between the plates. And then, with the battery still connected into the circuit, we insert between the plates a dielectric, which is a fancy name for the insulating material, having a dielectric constant equal to 3. We mentioned in an earlier video that this equation up here, number 2, is more appropriately written as the dielectric constant times epsilon naught times the plate area divided by the plate separation. If the dielectric is air or a vacuum, then this dielectric constant is 1, and so that's what you have here. But if you have something other than air or a vacuum, then the more appropriate equation is to use this, and you just take epsilon naught times A divided by D and multiply by the dielectric constant. When you add a dielectric having a constant of 3 in there, the new capacitance is going to be 3 times what the old one was. Anytime you put a dielectric in between the plates, displacing the air or the vacuum that was there, the capacitance is going to go up by that factor. What about the new voltage compared to the old voltage? This capacitor is still hooked up to the battery. It says right here, the battery is still connected. So the voltage is going to be held constant by the battery. A justification for that would be that the battery is still connected. So the voltage between the plates, the potential difference is going to remain the same. Based on the definition of capacitance, what do we have now? The capacitance has gone up by a factor of 3. The voltage has stayed the same. That means that 3 times as much charge now is on the plates. When we put that dielectric in there, more charge moves onto the plates in a little bit of a time there. For a parallel plate capacitor, that equation holds. D is the same as it was before. The voltage is the same as it was before. So the electric field must be the same as it was before. We haven't changed the separation between the plates, and the voltage stays the same as well. Therefore, the electric field has the same magnitude as what it did originally. What about the energy compared to before? You could use any of the energy equations here, but I like to use this one because there's nothing squared in it. The amount of charge has gone up by a factor of 3. The voltage has stayed the same. Once again, this factor of 1/2 has always been there. So whenever you're figuring out how much the energy has changed by what multiple, you don't consider that 1/2. You just look at how has Q changed and how has V changed. Q has gone up by 3, V has stayed the same. Therefore, the new amount of energy, 3 times as much energy. Let's do one more example. We're going to do essentially the same thing here, but now we're going to disconnect the battery from the circuit, and then we're going to put our dielectric in there. Anytime you put a dielectric in there, the capacitance is going to go up. So it's going to be 3 times higher than what it was. Because the battery has been disconnected, the total amount of charge on the plates has to stay the same. The battery is disconnected, so Q is on an island. It's isolated. It's got nowhere to go. It's on an island with no bridges, stuck there. What about the new voltage between the plates? Let's see. If we look at that equation right there, what would this tell us? The capacitance has gone up by a factor of 3. The charge has stayed the same. So that means that the potential must have changed to 1/3 of what it was. Isn't that true? If I put a 3 here for capacitance and I've got a 1 for the charge, then the voltage has to be 1/3 of what it was. So the potential between the plates has dropped by a factor of 3. How about that equation right there? The voltage is 1/3 of what it was. The plate separation has stayed the same. We haven't messed with that. Therefore, the electric field that we have now is only 1/3 as strong as what it was. And lastly, again, you can use any equation you want here for energy. I like to use that one. The charge has stayed the same. The voltage is 1/3 of what it was. That means that the energy is also 1/3 of what it was.